This is code.org, and we are, well, getting started. Import your painterplus.java from your backpack. Cool, we definitely have that. Backpack, painterplus.java, and I'm hitting import. Ta-da! If you do not have it, or if yours is broken, make sure to hit new file as they state here, name it painterplus, and copy the code over. Alright, now what are we doing? Create the BackgroundPainter class. Awesome. So I'm excited. We're creating a whole new class and, well, it's going to paint a background. Let me hit new file and BackgroundPainter. Make sure you capitalize the B and the P. Everything else lowercase and leave the .java. In the BackgroundPainter.java, import the neighborhood package on the first line. So this slightly bothers me in that we are importing the neighborhood package. This asterisk in Java would actually mean we're importing all files of that package. But regardless, they want us to specify painter as shown here. So I'll do it. Ta-da! Write the class header for the BackgroundPainter class. Oof. So I know we haven't done this a ton, right? It's not like we've made a million classes. And so two things. I would plug looking at your other files, right, to reference. Programmers reference other material constantly, but also code.org provides us so many resources. If I scroll way down here and hit show me how, right? Maybe you're a bit rusty. You're like, I don't remember every detail of the class header. Here we are. Look, a subclass uses the following syntax. I'm actually just going to copy this, copy. Go over here, hit enter, and I'm going to go ahead and paste. Now, obviously, these names are wrong, right? Our class isn't going to be named subclass. They told us right here, our class is BackgroundPainter. We could also look at the name of the file. So, BackgroundPainter. Now, what does it extend? Well, don't forget to extend the Painter Plus class. Yep. And then write the constructor signature for the BackgroundPainter class. Well, since we used our resources on line 5, I have public subclass. And so that will be my constructor, BackgroundPainter. Let's review public class BackgroundPainter. This is the name of this class. And then extends mean it is built on top of Painter Plus. So everything Painter Plus can do, BackgroundPainter will have access to. Remember, Painter Plus actually extends Painter. So now, since Painter Plus can do everything Painter can do, BackgroundPainter can do everything Painter Plus and Painter can do. What does super mean? Right, so the constructor is what runs when we have new, when we make an object over here, and we have new, BackgroundPainter. That's what's going to trigger the constructor. Super means, hey, computer, grab the parent class and also give me access to that. So give me access to the BackgroundPainter, but super, the computer says, what the heck is super? And it starts to look. Well, what's above this? Something super, it's above it. Oh, this is built on BackgroundPainter, and that gives us access to that. So now, write your method to create your BackgroundPainter that you planned in the BackgroundPainter handout. Let me head over there, magic my way over. Let's talk though about, this is the end goal, so it's always good to have that image available. And this is the UML diagram. In Painter, we have access to all of these methods, right? We can use these as we complete ours. In Painter Plus, we have this along with others that maybe we should throw in here. And Pattern Painter, we also have these, right? I went ahead and added in the red here, this is going to be BackgroundPainter. I know we're going to at least have paint background, and so I added that to my UML. Now, we'll likely have other methods that we could add as we go. For pseudocode, guys, what I'll say is, first off, these questions they're asking us are great, and so I want to hit upon them. The painter will hit the O. How will you know when to go to the next row, right? Well, this is a huge clue for me because code.org is telling me, hey, when you make this program, this is probably key. Moving to a next row is probably something important. So that means maybe we'll have a method just for that. I'm not sure, but good. It's a thought. The painter will hit the wall, therefore the painter will not be able to move. What do you need to do to move to the next row? I mean, we're going to need to turn and go south and then move. How will you know whether or not to paint? It's a background, so we're painting a background, so don't paint over stuff. And then do you need will you need other methods? Yeah, that's pretty likely. Now my pseudocode, I kept it super simple. I'm not gonna go through every tiny idea of pseudocode. My goal of this tutorial is to build and demo to show as I do so. I have a really rough, super broad idea. While the painter can move, we're going to need to paint a row. So maybe this will be a method too. I'm not sure. And then go to the next row, right? And we could add details here, but again, super rough there. You do want to have a plan. It will make you a better programmer. This is the thing professionals do all the time. So plan it out. It might not be perfect, but it will help you understand and do better in this course. And I'm right. Okay, that being said, let's head back over here because I would like to focus on actually showing you as we build and demoing the functionality. Right off the bat, I know we didn't need the method signature. So public void, and then it's going to be paint background. And I'm using public void. Public is the access modifier, meaning we can use it anywhere. Void means it doesn't technically return something. And if that doesn't make sense to you, don't worry about it. We'll learn more about both those as we go. Now I'm missing the parameter, right? We were going to allow the color. So I need to write the word string with a capital S, and I'm going to use what they suggested, which is color. What I am going to focus on first is the movement. I know we need to get to every one of these little dots. Certainly we will need to paint them as well, but right now that's my primary concern. Right off the bat, guys, I'm like, okay, I need to move. We know we have this method, move. It makes the painter move. But we should chunk this though. And what I mean by that is obviously we got to get across a row. We got to touch every one of these dots, right? To check if it needs paint. I don't want to write move a million times. And we've seen this a bunch. How do we repeat code without writing something a billion times, right? We definitely don't want this. This is awful. That's ridiculous. We don't need to do it. A computer will already repeat code for us. And how do we do that? Your friend and mine, the while loop. So while some condition, right? While something, I don't know what yet, so I'll leave that blank. But I'm going to put in some curly brackets and hit enter. So I know I'm going to need to move, and I don't want an error. Let's go ahead and take a look at this. So we need to ask a question while something is happening. While what should we ask? What I really want to see here is while you don't hit a wall. Except we've done this before throughout this course, right? What's an option? We need a Boolean because that will be a true-false statement. Bam, right? While we can move. So what that will do is it will allow us to check each step and move if we're going to smack into something, right? And if we are, it won't run this code. And as we've seen before, this move now will repeat as long as the painters can take a step forward. Right? So over and over, the second the painter can't take a step, like if they're facing this wall, this is false, and it's done running the code inside the loop. So super basic right now, boom. I'm going to leave it like that. Let's test this. It's not going to run as of yet, though. We have to instantiate an object, right? And that's just making an accessible instance. BackgroundPainter, capitalize. I'll use their format, which is to use my for the object name. New background painter, parentheses, semicolon. That will make our painter, and now I need to ask the method to run by calling it. We don't use the color parameter yet, but I still have to put something in here for later. I'll throw in red, and let me hit run. But right, we got to the end of the row. So cool. Let's go back to our code now. That's successful. I don't see an error. All right. We moved, which is great. We don't just want to move. That's not this assignment. We need to paint as well. We're a painter. So if I look at their example, right, here or over here, either way I notice that it seems like they will want us to paint the first square if necessary. We wouldn't want to leave a blank. So that means we know we start right here. I wouldn't want to do this, is what I'm saying. Because if I do that, I'm going to move, plop, and then skip over this. And this is a background. We might need to paint that square. So instead, let's do this. I'm going to put paint here first. And again, we're going to use the parameter, right? This word color is going to represent whatever color is put here. And now let's see what that does. Oh yeah, I need paint. So let's take a look. We can actually test this by get color. Oh, did they not? Oh, that is adorable. Okay, well, secret menu time. You guys have seen this in the slide deck in class, but this is all the methods of the painter class. And you'll notice this one is what I'm going to use because you should be able to test code while you code, and it's called set paint. It just means we can give our painter, some paint, so this doesn't bug out on us when we want to test. So, and I'm going to do a crazy big number just to make sure it's enough. Let's try again. All right, real quick, guys, I want to plug at least once what is happening here. A while loop runs as long as this part of it is true. So when this first gets here, when we first run this, the computer, I'm asking a question. Hey, computer, while we can move, and the computer goes, I don't know if you can move. We would be stationed right here or sitting right here. So it says, I don't know, smack. And it says, oh yeah, you're faced this way. Yes, you can move. And computers would say true. Honestly, computers would say 1 because of binary. Just fun fact, 0 is false, 1 is true. But anyways, computers would say true, yeah, you can move. So if we can move, the code in this curly block has to run. It's required. And so then it says, okay, got to run this. And we throw down red paint right there, and then we move 1 step forward, plop. We then hit the bottom of this while loop, and it says, oh, I'm at the bottom, I have to check again. Because I have to, before jumping out of this, going to another line, this has to be false. So I have to check. If we're standing here, we would still be able to move. Therefore, this is still true. The computer checks, it's true. We get to paint again and move again. Plop, 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 plop. And notice we're only going to paint if we're able to move. That's why this last square has no paint on it, because we weren't able to move. We're facing a wall. So, a few things. This is a background painter. I know we don't want to paint over other stuff. So that, to me, means a condition. What could we check, though? I need to basically say, if there's no paint here. And I'm going to want to use an if and not a wall, right? Because it's 1 square at a time. So let's go look over here at what we have access to. So if there's no paint here, let's see. You need a Boolean. It needs to be true, false, has paint. Ooh, right here. That's a solid thing to use. So let's go back and say if is on paint and then curly brackets and an if. I'm going to move paint into this. And this doesn't work yet. Why not? Well, how does an if statement work? An if statement means only if, it doesn't repeat, right? A while runs as long as this is true. If will only run once, but it will only run if this statement is true. Oop, I missed parentheses. So right now we're asking the computer, hey computer, am I currently on paint? But that isn't what we need. We need to know if we're not on paint, because we're only going to paint if a square is empty. So not is really what we want, but for Java, you just do an exclamation point right now. And now we're asking the computer, hey, are you not on paint? Are we not on paint? That's what we're asking the computer now, and that's perfect. That's what we want. One more thing I want to pay attention to, right here. We have a naked square. So I'm going to, this is for 1 row, I'm just going to throw paint here, right? And that way I know we always paint the last item. However, once again, keeping in mind, oh yeah, I only want to paint, right? I'm only going to paint if there's nothing there. I'm just going to borrow this thing. Copy, and right, let me format that. So something I'm realizing, this is BackgroundPainter, right? But what do we do right now? We paint a full row. Since this does one task, it's pretty focused, it paints a row. Maybe I'll break this out into a method. Something like, public void, I'll call it paint row. Paint row. I would need to give it a color. Curly brackets, quapow. And so now, instead of this all being in BackgroundPainter, I'm going to take it and I'm just going to move it up here. Because this is an individual task. And so it's nice to have it organized in this way. It's also really great for readability, because instead of paint background, now to do all of this code, all I have to do is write the method's name. I have to call the method paint row, and then I'm going to pass the color. And now, bam. So that's a real nice way to keep things tidy, because instantly I can say BackgroundPainter, oh, what's this line do? Paint row. Whereas before, if I had all this down here, it's kind of harder to be like, that I think all of it, where's it stop? So perfect. That would make sense. Let's go ahead now and think about the next action. Painted 1 row, well, need to paint a lot of rows. So what's up next is moving down. To do that, I'm noticing, since I just did paint row as a method, independent of BackgroundPainter, move down, that seems like a contained action as well. So I'm going to continue with my strategy of having other methods just to keep it tidy. So I'm going to have public void. I'm going to call it next row. And again, method names are up to you. You might have a different method or have this all within one paint background method. Totally up to you. Next row. Actually, this won't need a parameter because I'm not going to have painting go on. I'll do curly brackets. So for next row, what do we need to do? Mr. Kaiser, you need to go to the next row. Correct. So that's pretty straightforward in my head, right? It is going to be a turn. Ooh, here comes the hard part. Is that a left? No, it's a right. Right. Okay, turn right. And then I need to move down, so I'm just going to do move. And, oh, we want to face down a row again, I believe. So turn right. Let's see if I ran into a wall. Seems possible. There was the infamous year where I fell flat backwards on my chair. Next row here. All right, so, and I'm putting this here because we're going to paint a row, and then I want the computer to run this. And real quick, method calls, the computer sees paint row and says, up, I got to run something. It hunts for paint row, smack, runs all of this code. When it's done running this code, it has to go back to here, goes to the next thing, next row, zoop, and runs it. All right. Perfect. So now we're facing this way. So what are we going to want to do? Well, let's see if paint row works. I think it will, honestly, because notice that this isn't direction dependent, right? We don't turn in our paint row method. And here we are at the edge. So now we're on the other side. It's not going to work to do next row right now because turning right is going to take us back up top. Next row. And take us into a loop. Okay, so there's a few ways this can be handled. We could have two separate methods. For now, I'm going to keep it contained into this. But I will need this method then to make a decision for me. It either needs to do this right turn move right, or what would be the other way, the other option, right? When we're way down here, it's going to be very similar. It will be turn left, okay? Move, and turn left. Right? Because now we're on the west side, so being on the west side, we'll have to turn left to go down the row. However, again, I need the computer to make this choice. If we are on the east side, I want to do this. So I'm just going to pseudocode this, which is also, if on east side do this, and then what? Well, else if on west side do this. So knowing I want some type of condition here, let's go look at, again, what code.org provides us. We need a Boolean. We're going to need a true-false statement to help us out. So, oh, wait a minute. Do you see what I'm seeing? I hope you're yelling it. Mr. Kaiser, I know. Actually, you're raising your hand. You don't need to raise your hand at home watching this. Anyways, is facing, right? So is facing east is perfect. Let's go back over here. And I know if I'm on the east side, if I'm over here, this is the action I'm going to need to do. Bam. Is facing east. Cool. Now I need to move this code right here. Because this is the way, this is the movement I should be doing if and only if I'm facing east. Now, for the other chunk of this, I could do if facing west, I guess. Except that would not work. And here's why. Because once we run this and turn right, we would be facing west. However, we have learned about else. Else, boom, boom. And what the else does, if this is false, the computer says, nope, you're over here facing west, dude. So this is false. The computer cannot run this code. It absolutely cannot because this was false. However, it absolutely must run the stuff in the else statement. So let me move this up, which is perfect because if we're not facing east at this point, right, we're going to be facing west. All right, with that said, boom, boom, let's give this a shot. I already had next row here, so it should be cool. And then it looks like we can keep going with this. And I'm about to delete all this because this isn't how you want to do it, so I hope you're already telling me the right way. Yep, that works fine. Why are we repeating ourselves? Of course, there's an easier way, and like we've already discussed, the while loop. While, parentheses, I'm not sure what I'll put there yet, but I'm going to go ahead and do the curly brackets so I don't forget. What are we doing here? When do we want this to repeat? Well, it looks like right? After I paint one row and I'm turned, we're ready to paint the next row as long as we can move, right? When we're in the air, if we hit a wall. But other than that, yeah, go ahead and paint the next row and then turn down, right? So that means we can probably use can move again. I'll give that a shot and see how that does. And then I'm just going to take 2 of these and plop, and let's get rid of all of this repeats. So now it should run as long as we can move. It will err. There's going to be one problem. Bam. So this is really, really good, and we're pretty much there. Why is this exception happening? Well, Mr. Kaiser, it's happening because you're smacking the painter into the southern wall. That is true. We are running our painter into the southern wall. And why? Well, let's see. We're on the west side at this point. I'm not going to get used to saying that. So on the west side, well, let me format that, which means this is running, right? We get to the end of here, and next row must run, where is the computer says, hey, painter, you facing east? Nope, that's false. So else is triggered. We turn left, plop, and then we smack our face into a wall. That's a problem. There's a few approaches to solve this. There's a way to do it by only asking if once, right? Instead of having 2 ifs here, there's a way to do this a bit more tidy. Now, let's go look. So, I know we want something to do with can move, right? To avoid a wall. Well, we have can move. But if I look at this, notice how they're still standing and facing west? Which does make sense, right? If I don't have to turn, so let's look. Can move. Oh, wait a minute, guys. Can move direction. We could ask about a specific direction as long as it's a string, as long as it's in quotes. Meaning, maybe I can ask, hey, can the painter move south? And so before even running next row, or running the code inside of it, depending on where we want the condition, we can check that. Let me show you what I mean. And for this, I'm going to delete this curly bracket because I'm going to add it down here. Bam. So what is that doing? Well, now every time we run next row, before it bothers having us move, it says, wait, is this even worth it? Can you go south? Because if you can't go south, why run all this code in here? We're not gonna. That's why we're checking. And if we can't go south, if this is false, it skips all of this code, which is exactly what we would want it to do. Ooh, a bit of formatting. And ta-da! We just wrote a bunch of code. I do want to point out, guys, with code, there's more than one correct answer. This is a correct answer, but there are many. There certainly are wrong answers too, but with code, it's about solving a problem, and just because you solve a problem slightly differently certainly doesn't mean you are wrong. It is absurd to even think that code has one correct answer. And just to kind of give you an example of that, what I mean is I've seen students have next row inside of here. Or maybe they even have this south around next row here, and they don't have it within this. I've seen students do this all within one function. I've seen students have a method just for if is on paint outside of this. There's a million ways to do this. I've seen students who use instead of wall can move, they negate this, so not, and they have a little bit of difference with their program. Or they have an if up here around move and turn left. There are 100 ways to be correct, and I just want to hit that home. Regardless, however you accomplish that, pat yourself on the back. We just did something pretty cool. Oh. Great. Onward.